This conference will now be recorded.
So just quickly recap the PIG program structure once again, and after that we'll start the hands-on part. And Naresh, I'm getting some echo. Please mute from your side, and whenever you want to speak out, just unmute from your side.
I'm muting it.
Yeah, thank you. Fine. So basically, whenever you want to process certain data using Apache PIG, so we need to remember these three steps. So initially, you have to copy the data from local file system to Hadoop. Then after that, a load. It's a kind of a file handler. So you're just defining a relation or simply a variable. To that, we're just giving the complete details of your data set along with the metadata if and all available. So that is the purpose of load. So once the data is available with a particular relational or I mean to say the variable, now after that you can start the transformation or simply the process by using some pig Latin statements like order, join, group, depends on your use case. So once your business logic is finished, so we need to go with some actionable commands like store or dump. So this is the final statement. So the moment you hit like store or dump, then pig starts the actual execution. So until otherwise you're not giving any store or dump kind of a statement at the end of your script, Pig still, it's wait for that because that is the actionable command and still waits for that. Unless otherwise you're not giving it, won't start any execution, right? So the moment you have given the dump statement or a store, then it will start the execution. Nothing but it's running some plans, logical plan, physical plan, and MR plan. Finally, it does the all MR process and all. So this is what we identified, right? This is about the Pig program structure really, how it looks like. Now, what we'll do, we'll understand a simple thing. Okay, what exactly, the tuples, atoms, and everything we'll understand. Then, after that, we work with some examples also. What do you mean with that schema and all everything? Okay, right. Now, first of all, what is a field, what is a tuple, and what is a bag? We'll understand it, right?
Yes.
Example, I'm having a small data set. Here I'm taking this. Suppose I'm having some product ID and some product name. That's it. Very small thing I'm considering here. Product name. It's a comma separated value here. So just I'm giving here. It's a 10 is a Samsung. 20 is some iPhone and some 30. I just have Nokia here like this. Right. So very simple data set I'm having here. So what's the field here? We know. So we are having two fields here, right? So here, what is the field here? Product ID and product name are nothing but the field names here, what we can call. It's just piece of a data, right? Even though you're having a lot of field names and all, some field names nothing but a piece of data because maybe you're having a lot of things in this. So here we can consider this product ID is a field, right? And this product name is also another field here. That's fine. At the same time, what about the tuple here? So what about the tuple here? So if you want to define a tuple, it's a set of fields. That's it. Okay, it's a set of fields. That's it. Right. So here in our scenario, ID and the product name, right? These can form a tuple. So this product ID and product name can form a tuple for us. So for example, let me take here. So this makes me really the tuple here. Okay, got it? So this makes me a tuple here. In similar fashion, what do you mean by bag here? You're having one more thing called bag. So bag is nothing but collection of tuples. That's it. A simple thing. You can understand. Collection of tuples. Okay. So this collection of tuples can gives us some bags here. For example, I'll take this. I'll write in a bags format here. So now, right. So this is my tuple one. Okay. And this is my second tuple. And this is my third one. Got it? So that's the basic idea. So whenever you're having such a data set, the data set you can take into or consider into fields, tuples, and bags. So field is nothing field is just simply a particular column that we can say. It's a simply sorry, open comma I'm getting sorry for that. So field here is product ID and product name, something like the columns or the column headers, what we can call as a fields here. And tuple is nothing but a set of fields, so nothing but a row that we can consider here. So this entire row can bring us a tuple here. And what about the bag here? It's a collection of tuples. So once you're having 10 comma the Samsung, 20 comma iPhone, and 30 comma Nokia, all this will give you the bag, nothing but list of or collection of tuples. That's it. So this is the basic idea that we need to keep in our mind. Okay, got the idea, right? Now, what we'll do here in our morning session, we're just talking about a schema, and at the same time we said schema is optional and can be provided in the runtime also whenever it's possible, right? So we'll understand how it can happen. So let us start our virtual machine. Fine. So here I'm having some data sets. Okay, I will understand schema here. So just here I'm having some sample data set here, right? I'm having some sample data set here. For the explanation purpose, I'm taking to here, right? So right, that's the data set what you're having at present. So just we are having some here also. I can say some product ID I'm having and product name and probably the product price, right? So now what we'll do, we'll try to take this data to HDFS initially, right? Then we'll try to load this data to some relations what we defined under PIG. So we'll do that. See, one more thing, in real time what happens, client will never give you the column headers. So they will give you the separate, description of this particular field names and everything. At the same time, sample files in I mean to say separately they will provide. If at all by chance you will be getting, the column headers or the field names, whatever it may be, along with your data. What you have to do, you have to remove these column headers and you have to load the data to HDFS. Otherwise, this will also be considered as a one more record. That's it. Okay, so please be careful. So whenever you, of course, there's some client policies and all, they will give you separately only, they don't mix up. Okay, even for our hands-on purpose also, whenever you're having any column headers, please remove the column headers before loading this data to HDFS. So the moment you loaded the data to HDFS, that's fine. Now you can work on. Okay, so right, please be careful about that. So anyway, here I don't have any column headers or the field names here. What I can do, I can take this data to HDFS first of all. That's the first thing I can do. And before that, what I'll do, I'll just verify my Hadoop server status here by hitting JPS. Fine. So my Hadoop is not at all running here. That's what we noticed. Just we zoom in this. Fine. So just let me go to the Hadoop installation folder and just start the Hadoop daemons here. Right. It's taking some time. It's taking this much time. Okay, fine. So let us start the history job history server also by saying /m job history daemon.sh. Okay, start history server. So this is essentially needed to run our PIG jobs. That's why. So right now just verify about Hadoop daemons here. So we got all the list here: data node, name node, job history, name, okay, node, and everything. So while this is done, you can go with the web UI also to verify the status, right? So then once your Hadoop is running and you got the confirmation, now what you can do to enter into the PIG, just say PIG. That's it. See, you can use PIG with a hcatlog also, table management tool, that I will show you later. Okay, this module just I will explaining how to enter the PIG shell, nothing but the grind shell, and how could we can work with that, and how to run the script. So these things we'll understand. And there is a table management tool called hcatlog. So along with Hive we'll work with that. That time I will show you how to enter into the hcatlog mode also. So now just simply say PIG and hit enter. I don't know, my system is too slow. It's responding very bad. Right. All right. So finally I got reached here grunt, right? So this grunt is nothing but the PIG shell. So the data what you are looking here is some sample data sets. or just copied for earlier sessions for some other demonstrations. Anyway, that's fine. So now we able to get the grunt shell. That's fine. Fine. Okay. Now where is our data here? This is the data. So here we're having a data with a name called my schema. This is my data set name here. So what I had to do, I had to copy this data to Hadoop or HDFS simply. So just I'm opening one more terminal here. That's fine. Okay. Now here, just go to the respective location by saying cd desktop and cd. I think there is a data folder called PIG-2. So this is the directory what we have and where we have all the data sets here. Here you can see. So these are all some data sets what you're having. And out of which just now we want to take a data set name called my schema to HDFS, right? This is the data one, right? Right. This is the data set what you want to take to HDFS. So how we can take this? So either you can use the put command or get from local. Both are identical. So you can use your own. So I'm using the put command here. So how to use that? HDFS DFS minus put. Okay. And provide the your data source name or simply dataset name and provide the location. So what this indicates here, we are indicating you are copying the data which is available in this location to HDFS, nothing but to data node or nothing but simply Hadoop system. Storage area, just we copy it. Actually, should not be like this. It's taking a lot of time unnecessarily, right? Fine. So same thing, just we can cross check or cross verify here also. Here you got the data, right? So look at this, it's just having a 65 bytes, that's it. But default is 128 MB, but it is not identified. We discussed that later. Sorry, not later. We discussed already the use case, right? That's fine. So now we got the data here, and you can't modify the data. Once the data is reached here, you cannot update and all, right? If you want, you can append something, but you cannot update anything here. That's fine. Now our data is available in HDFS. So successfully we have completed the first one here. Okay. So this is what we did here. Now, anyway, I just earlier I have opened the grunt shell, right? I just go to the grunt shell once again. Yes, here. Now let me write something here. So I'm taking a relation called my SCH. So you can say my SCH is equal to load and your data set name. What is your data set name here? My schema. So just provide that. Okay. So what exactly this my SCH? This is just a relation. You can give anything apart from the peak result keywords. You can give anything here. Okay. So I'll explain this later. So my SCH is equal to load my schema. That's it. What I did here really? I just defined a relation. Okay. I just defined a relation called mySCH and I said load, and I just provided the HDFS location of the data. Nothing but I have given this information. Okay, I have just provided that particular information. That's it, not more than that. Okay, now here if you observe, I just have not given any details about the schema, like what are the fields it's having, or what are the data types that they really belongs to. If this is the case, okay, if you want to understand what exactly there in this relation, how we exactly pick stored internally, so just we can go with a command called describe. So let us describe here. Okay, let us, yeah, otherwise what I will do, I'll just copy this for you so that you can understand later. Right, so this is what I did. Now what I'm trying to do here, I just say, you can write describe or desc is also sufficient. Describe. So what's our relation here? Our relation is my SCH. So this is my relation here. So you just say my SCH. That's it. If you look at this output, it's saying schema for my SCH is unknown because completely, Pig is no aware of how many fields it's having, right? So this is the output what we use just now, right? Schema for my SCH, nothing but the relation is completely unknown. So your pig is not having any idea how many fields you're having and what the data that they really belongs to. Now what we'll do, we'll just modify this particular statement, okay, by adding some fields to that. So look at here. So I'm taking one more relation called my SCH1, nothing but my second relation. I'm saying load my schema, that's fine. Now here what I'm doing, here I'm saying using, okay, using pig storage, using pig storage, and just you provide the details. This is a comma separated values or data, so just provide the comma here and you just provide the schema as well. So just I'm providing the data types. What are the data types I'm having here? For example, I'm having the data types as some product name, product ID, product name, and product price. That's it. Okay, right. So let me give here. But if you observe, I have not given anything. What data types that they really belongs to. Just hit enter. That's fine. Now I'll try to get the schema information by saying describe once again. So right. So this is what I did in my second statement, isn't it? Now right. So what we'll do, we'll say describe my SCH1. This is the one. Now look at here. So I had just given the product name and product ID, name, and the product price. But if you look at here, it's given the default data type as a byte array to all the big fields here. So this is the entry question. In like some of the people will ask, if you're not giving any data type for a particular field, whether it is taken by pig or not. If yes, what's the data type the pig is going to give? So this is the answer here. Got it? Here you can see we had not provided any data types for our fields. So it's giving byte array. That's it. So this is the output of what we verified here. That's great, really. Now we just modify this stage a bit more by providing the complete information. So for that, nothing but complete schema. I'm taking one more relation, my SCH2 here, and same data. I'm not changing any data here, but this time I just am giving the data types here, like product ID is an integer, and product name I just am taking this as a char array, and product price this I'm giving as integer. Okay, so this is the third variation just I would like to show you. So now what happens? We'll see. Fine. So here we just say describe my SCH2. We would like to get the structure of this. Look at this. Default byte array now replaced with our given data type like integer, char array, and the integer. Got it? So this is how really big behaves and accepts the data here. So schema is really not a big question for Apache PIG. So it considers the data if you're providing. So complete, you can omit the metadata. I mean to say the schema you can, or what you can do, just you can provide the field names, and now the byte arrays will be assigned to each of the field name. Otherwise, if and all the client is providing the details of the data types, just use specify that. That's it. Okay, fine. Is this fine? Can I get a quick confirmation that you have followed this or not?
Yes, yes.
Fine, great. Now we'll understand the data models and all. Okay, different thing. So fine, we'll keep like this. So here I'm having a data set called data models here. What exactly that? We'll see that first of all. Right. So of course I'm having some blank space also here. Sorry for that really. So here if you observe, just I'm having some numbers here. Okay, it's a what? It's a purely I'm having 3 columns here. That's it. So this is column 1 and this is column 2 and this is column 3. So simply just I'm having 3 columns in my data set, and now what I want to do, I want to observe few things like before we're discussing about atoms, tuples and everything, right? Now just we'll try to find out what exactly they. Okay, so let us do that. So to understand the atoms, tuples and everything, what we'll do now, we'll do a small exercise on this particular data set. So what is the first step we had to do? So we had to copy this data set to HDFS. So that is the first step that you need to undergo. So it's very simple. Just you say, okay, HDFS, DFS minus put, the data models to HDFS. That's it. So data set is now available in the HDFS here. Here you can see the data models. So the data is now available on the HDFS. That's fine. Now we'll go back to the Gren shell here. Now we'll try to understand what you mean by bags, tuples and everything here. Fine. Now just write some simple, statements here, big Latin statements. Something like, A is equal to, what's A here? It's a relation, it's a variable, that's it. A is equal to load, and you just provide the data set location, data models, okay, as oh, as just I'm providing the schema information here. So 3 columns I'm having. C1 is an integer type, and I do have some C2, nothing but column 2. Here also I'm having some integer, and finally I do have some C3 also, which is also integer here. Okay, so what I did, I'm taking a relation called A, and I'm loading the data models, the data set, along with the complete schema information. This is what exactly I did here. Fine. Okay, so now what we'll do, earlier just we are just giving the describe and all, right, to get the schema information. If you say describe A, then you'll be getting the, here you can see this is the relation, and this is having the schema like this. C1 is an integer, C2 is an integer, and of course C3 is also integer. So now this data models, the data set, along with this schema completely available with the variable called A, or with the relation called A here. Now what I will do is I'll say simply dump A. Okay, I'll say dump A. Actually, if you see, our data is looks like this, right? So we are having a data like this. Now what I will do, I will say dump A. Now you can see here it started the execution, started a lot of plans in the background. So for simple, A is equal to something, it's doing a lot of nonsense, right? It's running some, here you can see it's launched the map reduce launcher and all. So once here you can see the information also. Processing aliases A here. For a simple thing, it's taking a lot of time. Of course, not a problem. So on top of an architecture, now we are running the PIG. Okay. So resource management will be taken care by your air, and processing will be taken care by map reduce patterns here for PIG. So finally, once it's redirected to history server, you'll be getting the output here. That's fine. Okay. So now we got the output on the console. Look at this. It's giving all the in a new way, right? But our data is something like this. Where is our data? Not this one, sorry. See, our data is something like this. Okay, but how really PIG is storing this data internally in a relation? So this is known as outer bag. Okay, so this is known as outer bag. So whenever you're taking the data set to any relation, that will be stored as by default as outer bag. Please do remember this. Okay, so this is known as outer bag. Anything you just give, okay, any data just you load to any relation, but by default PIG stores the things in the default format is outer bag. So this is quite different, right? So this is the data what we have provided to PIG, but PIG stores the data in this particular here. That's it. This is the data what we have provided actually. Now let me write something called data models here. That's fine. So that you can review this. Right. That's fine. Now what I will do is here, I just group columns based on my first relation. So let us do that quickly. Here. Right. So I'm taking one more relation called B is equal to group, okay, my previous relation A by C1. C1 is nothing but my column 1. So what I'm writing here, what is my business logic? So just I want to group A, nothing but earlier I'm having the data set, right? Nothing but this. So just I want to group this A based on the column 1. So it's having 3 columns, right? So it's having something like C1, C2 and C3, of course. Now what I want to do, based on this particular column 1, I want to group the data here. That's what exactly I have mentioned in this particular thing. So I want to group this A based on the column 1, and I want to store the result back to a relation called B, or an alias called B here. That's it. Right. This is what we want to do. So right. Now let us hit enter. Now we'll verify. Let's say dump B. To get good speed in real time, these will be used. Okay, on top of here. But as a developer, we doesn't mind whether you're running a MR job or this. We doesn't care about that. But anyway, we got the output here. So now we'll try to analyze this output. So this is the output what we received. That's fine. Now we'll try to analyze this particular output. So if we observe here, I'm having few things like I'm having some keys, and I do have some bags, and I do have some tuples also. Okay, in this particular output. And of course atoms also. Right, we just have all the things here. We just are having the keys, having the atoms, and tuples, bags, and everything here. So what are the keys here really? Okay, out of this particular thing, what are the keys? So here if we observe this, based on this column 1, okay, we just group the data, right? Now this 1, 2, 4, 6, which belongs to column 1, behaves like a keys here. So here I'm having keys like 1, 2, 4 and 6, of course. So this will become my keys here. The moment I group the column 1, right, I insert this result, and the column 1 I'm having 1, 2, 4, 6, right? These values becomes the keys for me here. That's fine really. What about bags here? What are all the bags that I'm having here? Before going the bag, what are the tuples I'm having here? First of all, what is a tuple? It's a set of fields, right? So set of fields can be considered. So this is a bag. So this is a bag. This is a bag, like this. So these are all bags, right? Of course. What is the atoms here? All individual things will be atoms only. 1, 1, 9, 9. All this will, all are these atoms only. Individual fields. That's it. Your 9, 1. Once again 1, 3, 2. That's fine. So what about the bags here? How many bags I'm having, first of all, and what are the bags? It's a collection of tuples, of course. We'll talk about the bags later. But what about the tuples here? Just a moment. I copied somewhere wrongly. Right now. So in this particular data, so what are the tables first of all, and how many tables that we are having here? Can I get the count?
Yeah, like 10.
So tables. You're giving the count for tables, right?
Yes, like 1999, 132, 123, correct?
Yes.
Yes, that overall like 1 2 3 4 6 like that. Like
So
you can
you're
go on.
saying total 10 tables are there, right?
Yes, yes, yes.
But I'm getting 14 here.
14?
Yeah, I'm getting 14 here. So this is also a complete row, right? This is also
Yeah, yeah,
equal.
yeah, yeah. Yes, 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 yes,
Got it?
yes, yes.
That's fine. So now, how many bags I'm having here?
Uh, 10?
Collection of tables, right?
Yes.
Yes. So one, this is completely a bag.
Oh, okay, okay. Four,
Second,
four, four, four.
yes, 4 bags I'm having.
Yes.
That's it. Is this fine?
Yes.
So right. This is what exactly we received. So when you're like you're working on this, right? So please understand the terminology here. The keys. Whenever you're grouping on a particular column, you'll be getting key and the values. So this is a key and this is the value for this. Of course, I have not specified this. So once you're calling this as a key, and you can consider this as a value for that. Something like hash map, that what we call in real time. Hash map, I think you know about, right? So you're having certain keys and the values pertaining to that. So here, the key, when you're talking this as a keys, it cannot be duplicated. So generally, we are having a concept called hash map, where you're having keys, a list of keys and values. Okay, we are having certain keys and values here. So these keys cannot be duplicated, cannot be duplicated here. And coming to the values, can be duplicated, can be duplicated. That's fine. So that's a simple thing here. You can see this is the 1, 2, 4, 6. So these are all unique here. They cannot be duplicated values. But here you can get some duplicate values also. So this is a simple analogy what you can refer when you see you're talking about any key value pairs. So for example, in real time, with the same name like Naresh or Anil, you can have or you can find a lot of employees in your organization. For example, the same name called Naresh, you'll be finding 10 employees in your organization. So it doesn't mean that all of you are going to get the same employee ID, right? You'll be getting a different employee IDs. Even though the value is same here, the value is Naresh here, the employee name, but it doesn't mean that you are giving a single ID or the unique ID for all the employee names who are starting with Naresh here, right? Your employee ID will be different here. That cannot be unique here, right? But you can have the duplicate values like you can have you can have the same name. You can find same name like with a Naresh, but it doesn't mean that all of you going to get the same employee ID here. Okay, so keys cannot be duplicated here, and values of course can be. You can have the same values here. That's about. So this is about and one more thing, the result what we here received is known as inner bag. I have not mentioned here. This is known as inner bag here. That's fine. Simply we call this as an inner bag. That's it. Fine. So what we'll do, we'll just take a 5 minutes quick break and we'll continue about the remaining hands-on part. Okay.
Yes, sure.
Yeah, please let me know. Are you comfortable with this? Are you understanding the things what you
Yes, yes.
the basic
Absolutely.
technology? Okay, fine. You're fine. Shall we start?
Yes, right.
Fine. Right. Now, we'll work with some more examples. So, yes. So here I'm having two data sets like, student and the result. So this is my student data. I'm having such students like, on the limit, like the way just I'm having students along with their roll number, you can consider, or register number, what it may be. Now, on the other hand, I just am having the result data set also here. Okay. So here I'm having the student IDs and the status, whether the student is passed or failed. But finally, what do you want to do here? So all the given data set, right? First of all, we need to join these two data sets by using this register number or roll number, whatever it may be. So once the moment we joined, what we require really is we just required only the passed student. So out of 9, some of the students got failed. So we are not interested with the failed one. We want to retrieve only the passed student. That is our problem statement. Okay. So we are having two data sets here, and these are the field names what are having. So in one data set we are having just a student name and the register number, and the other result data set we are having the student ID or the register number, we can say, and the status whether the student got failed or passed. So we need to join this, right? And finally we need to exclude the failed one. That is our problem statement. Now what's the first step we have to do? As usual, just copy these data sets to Hadoop. That's the first step. So how we can copy? HDFS, DFS, minus put, and student, and the result. So each time just you copy the two data sets here. All right. Now you can verify here. Okay, we got our result and student data sets here. That's fine. So what we're writing here, just we are writing some big Latin statements individually in the grunt shell. Apart from that, what we can do, we can write the same thing in the script also. Okay. So what I will do is initially we'll run the things from the grunt shell and we'll understand the analogy, and we'll just copy the same step to a notepad and we'll provide in the script. I'll show you both the ways how to run for the same thing here. Right, let us start here. So now we are very much clear and we copy the data sets as the HDFS. Let us write some big Latin statements here. That's fine. So you just take a relation kind S. You can take any relation. I'm taking S here. S is equal to load, and I want to take student as we are having student name is a char array. Just I'm giving the data types also, and I have the role or roll number. You can give anything which is a integer type. Okay, fine. So here I can take this. Okay, I'm remove this. Right. Similarly, I'm taking one more relation called or. Otherwise, just I'll modify the statement instead of writing from the scratch. So I'm taking a relation called R, okay, and here I'm saying load result as, so we are having roll number and status. So you can take this as roll number, you can give anything, so roll number and the status. I can define this as a char array. That's fine. So this is the second one what we did. Fine. That's fine. Now we'll try to write the business logic here. Okay, fine. Now take one more relation. Join DS. This is my relation. So join DS is my third relation. So here I'm writing the join statement. Join yes by this roll number. Okay, comma, or nothing but my second relation by this R and O. This is what exactly we are doing here. Okay, that's fine. So let us give the same statement in the console or the big shell. Now if I say dump join DS, what happens? We can verify, right, whether the join data sets join properly or not. We'll see. Okay, if you look at here, we able to join the data sets, but here this is not required. It's copied here in 2 times, right? So we just required only the student name and the status here, right? We are not required any the anyway the roll numbers and all. So we'll write that in our next step here. So we'll take one more thing by saying result ds. You can take here, and now you'll write for each statement here. So for each, okay, join ds, nothing but my previous relation. Okay, generate name, this one student name, and the status. Okay, because we don't require that roll number here. Generate name and status, that's fine. Now if even though you're doing this, still we are getting the passed and failed students, both are we getting, right? If you say this, And if you say dump result ds, we are getting both the passed one and failed one. So to get only the passed student, we can use the filter statement here. Okay, let me write here meanwhile. So pass ds is equal to filter and your previous relation, nothing but result ds by status matches. So you can say is equal to, or you can say matches. Both works here. Matches, pass. That's it. You'll copy this. Yeah, it's still doing. Okay, you got it. It's retrieving both the records, failed and failed records also. Now if we give this, now it will filter the things and this will be removed. The record belongs to Arshad and the Smith. Both are going to be avoided here. If you say dump past ds, that's it. Meanwhile, we'll just understand. We understood how to dump the right, how to result can be dumped into the console. But if you want to store this result, maybe in future you want to work with the same data set for different purposes. Maybe your Hive team or MapReduce team want to work on the same data set what you have joined. For example, see, doing this particular join operation is very cumbersome process in MapReduce. You have to write tons of code there. So here we simply use the primitive statement, nothing but the join statement, and we use to join that. So in real time, what happens instead of for joining these two tables, instead of writing a tons of code, you can do that in Pig or Hive simply, and after that, based on the result, you can work on that. So that's a reason. Sometimes what happens, instead of simply dumping nothing, but if instead of simply viewing the result on the console, we need to store the result on the HDFS also. So how to store this? So you can use the store command like this. So instead of dump here, I am showing store here. So just say store, and what you want to store, this is the one you want to store. Your previous alias or relation or variable. And now say into provide the HDFS location. I want to save this in something like Naresh output one, some folder. See, this should not be exist in the HDFS earlier. Okay, we are not having any folder, right? The name called Naresh OP1. So that's the reason I'm giving this location. Now what happens? The result what exactly you're getting on the console like this will be stored at HDFS in this location permanently. That's it. Okay, if you say store and your relation name into and provide the HDFS location. That's it. Now I'll show you how to run this as a script. Just I'm taking all the statements. These are the only statements, right? What we use to execute this. So just I'm copying these statements. Then what I will do. So here, just here I'm going with an editor, gedit, and put some name to this. Like you can give anything, any name you can provide. I'm giving here Naresh joined one. You can give anything here. So gedit Naresh join one dot pig here. Like Java programs, we are having dot Java, and for Scala, you are having dot Scala extension, right? In a similar fashion, for the pig script, you should have this one. Your script name followed by the dot pig. Right, and just you take the things here. That's it. Your script is over. Same statements, right? We are not writing anything new or more than that. So right, so script is ready here. And to run this script, now after saving this, you can close this. So to run the script, no need to go to the grunt shell. Okay, no need to go to the grunt shell, no need to run from here. Straight away you can run from here itself. Okay, if you say ls, so if you say ls, here you be getting right. Where is that, Naresh? Somewhere. Hmm. I think it's stored somewhere. One second. I have not provided the location. Yeah, here you can see ah type error. So join when n is not properly came. That's fine. So I got the script here, right? Now I can run the script here locally. So just say pig space and your pig's script name. That's it. So no need to run this from your grunt shell. Nothing to be run here. So you can happily run from here. Pig space. How to run the script? So just say pig followed by your script name. That's it. So the advantage here is the log file will be created locally. So whenever you did some mistake, right? So generally the shells are not user friendly. So instead of that, what you can do, you can write, and of course, yeah, fantastic. We got some error here. Look at this. You got the error, right? A log file will be created locally here so that we can go and rectify our script and we can rerun the script here. Okay, that's fine. Right, fine. So this is the one. So here you can see this is the one, right? Desktop pic ds. So here the log file is created. Just open the log file, and here it's having some problem. So error during parsing, lexical error at line 14. So it's having some additional thing and all. So we just go and verify our script here. Okay. So where is the script here? So this is the one. Just open that. Okay. Just open that. Oh, you forget to queue this. That's it. That's it. And remaining stuff, there is no problem at all. Right. Now just rerun once again. Fine. Just rerun once again. Okay, take some time anyway. I think you have to start the server once again so that it may get some speed. Right. Great. So now we go and verify the output in the HDFS. Just say refresh. So Naresh OP1, this is the directory what we asked it to create. And if you click here, you'll be getting a success. This is nothing but the status message and part hyphen r hyphen zeros. So this part means partition and r means the final output is provided by the reducer. We know that mapper and reducer, right? So and finally you'll be having some zeros here. Got it? So this is nothing but the partition number. So sometimes what happens, in some certain programming, we'll be working without the reducer. So everything will be working on top of the mapper only. In our coming examples, I'm going to show you that. Okay. In some joins, what we're going to do, intentionally, we want to do everything on top of the mapper. So we don't want to do anything on top of the reducer. So that time you'll be getting an output by saying part hyphen em hyphen and followed by the partition number here. Okay, got it? Part is nothing but the partition and or stands here the reducer. Nothing but this is provided by the reducer, the final output. And this is the number here, partition number here. That's it. Now you just click on here, you got the output here. That's it. So now you can take this data to your Hive tables, or you can process this data with your HBase, or maybe other tools can process this particular data further. Got it? This is how the things can happen. So same thing, right? It's also up to you whether you want to work on the grunt shell or you want to work with a script. It's up to you. Whatever maybe you feel more comfortable, you can use that. That's it. Fine. So now we'll run one more example on joins before going to the advanced level of joins here. So hopefully you are having good idea on these joins and all. So that's it. Okay, I'll show you normal, that left orders, right orders, and the full orders. So what I will do is I will write just the commands or instruction for that. So as an assignment, just give it try to execute and analyze the output, how the records are parsed and how it will be joined and everything.
Yeah.
Okay, yeah, fine. So I'm taking two data sets once again. Where is that? Once again. So right. So here I'm having two data sets. One is posts and yeah, this is one. User likes and user post here. So let us view the records here. So this is the one data set. Oh, honestly, just a moment. I just will cat because just we want to view. So this is my data set one, and this is my data set two. So here I'm having certain users like user 1, 2, 3, sorry, user 1, 2, 4, and 5. Sorry. And here I'm having some, post name, funny story, cool deal, interesting post, and at another blog. Like the way I'm having some, you know, the post name also. And I do have some Unix timestamp also, nothing but I'm having some date. So this is about my user post. Similarly, I just having one more data set like user likes. Here I'm having usernames like user 1, 2, 3, and 4. These are some records are common but not all. And if you observe here, I just having something like number of likes that they made for a particular post. Got it? So this 12, 70, and 50 indicates the number of likes that they made for a certain post, and followed by the timestamp, Unix timestamp, of course. So of course here you are having two common fields or common keys, multiple keys we are having. So you can join these data sets with the help of either the username or with the timestamp also. So both can be possible. So once you're having certain data sets like this, I'm repeating once again, in this user post, just you're having user name and the post name and the Unix timestamp. And in the user likes, you're having username and the number of likes that he made for a particular post. Was user, or maybe for this funny story, he made 12 likes. That's it. Like that you can understand. And you're having certain Unix timestamp also here. So that's what. And some records, these are all not matched here. Intentionally, I kept like this. So we are having a common records only 1 to 4. That's it. 3 and 5 are not present in both the data sets here. They're present only a single data set here. That's fine. Now, for these data sets, how to implement a big script for various operations like left outer join, right outer, full outer, co-group, and everything. So we'll understand that. Real time, it's going to be very much useful when you're dealing with a very, very bigger data sets and all. So let us write. So a script for this, instead of running from the terminal, what I will do, I will write a script here and I will share it to you so that please practice this from your end as an individual big Latin statements.
Sure.
Right. Yeah. Thank you. So let us open a script for this. Earlier we are having, what is that? Yes, Naresh join one. Okay, I'll take one more name here. So gedit Naresh 2 dot, okay, 2 join dot pig. So there's a second script. Okay, it's made available for me. So before writing the script, what is the first thing you had to do? You had to take the data sets to Hadoop. Please don't forget that. Okay, please don't forget that. How to take the data sets to HDFS? It's very simple, right? HDFS, DFS, and say minus put user likes and user posts. That's it. To HDFS. Now the data sets are available in HDFS. That's fine. Great. Now let us write the script here. So I'm taking a relation called P here. P is equal to load user post. So this is my data set name using pig storage it's a comma separated CSV value, so I'll be giving the same thing here as a comma here. If they are tab separated, you have to mention /t. That's it. As you're having user post and the data force, and now just provide the data types also. It's a long, and this post is something like char array, and the user we just give char array once again. That's it. So this is about my first relation. And take another relational L. I'm copying this to save the time. Sorry. That's fine. So L is equal to load user likes. This is my second relation. Using pig storage as user is there, no problem. You can keep as it is, and you just give the likes here. And this is an integer. We are having certain numeric values here, and date of course long here. Now user info 1. This is my first relation. How I can join these two data sets? It's pretty much simple, right? Join p by user comma l by user. That's it. So this is a simple thing. It's going to join the data sets, and once that is joined, you can say dump. Okay, you can say dump user info. This is how you can join the data sets. Or if you want to store, you can give the store into and give the location at the HDFS. That's it. Right. So this is how you can join the data sets. So this is indicates a commenting. That's it. Similarly, how to join with multiple keys? Join by multiple keys. How you can join? It's very simple. I'm taking the same thing. Okay, you can say user info 2, take one more relation like this, and join p by user. So date is also right, there is a common. So user comma date, and l also by user comma date. That's it. This is how you can join with multiple keys. Okay, right. Similarly, how to do the left outer join? So what happens if you do the left join? Now in our scenario, records from the post pack is going to be happen even though it's not having any matches with the likes pack. That's it. Okay, so that's exactly has to be happen. So just provide a take one more relation, take the same thing. So and we'll modify. Okay, user info L I'm taking. This is my relation to indicate the left outer join. So join p by user. Okay, just say left outer. That's it. It's very simple. Left outer. That's it. Okay, join post by left outer. That's it. L by user. Similarly, if you want to do right outer, I'm taking these two things so that I can do very fastly. So this is about my right outer. I'm taking one more relation called user info or. Okay, so join p by user right outer. That's it. Instead of left, just right outer. Right outer and L by user. That's it. So then what happens if we do this right outer join? It's exactly opposite to our left outer join, right? Records from the second data is going to be included, even though it's having some unmatched records. That's it. And those are going to be replaced with a null value. That's it. If and all any mismatches found really. So this is how you can do the right outer join. What about full outer join here? I will understand full outer also. So full outer join, coming to this, what happens, records from the both the data sets are going to be included, and whenever it find any mismatched records, those going to be set to null. That's it. Okay, both will be included. So I'll take one more relation called user info ef to indicate full outer join. So join post by user, just say full outer. That's it. Not more than that. Nothing is required. Okay. Similarly, you can go with a co-group also. So co-group means what happens? By default, it provides the outer join. Let me write here. If we do co-group, what happens? By default, it provides, okay, outer join. That's it. So how to write the what is the syntax for this? So take, okay. So user info CG you can take to indicate the co-group, okay. And here co-group P by user and L by user. That's it. Okay. So this will be co-group your data. Just now we understood, like, by default it's going to provide the outer join, but you're looking to get some inner join. Okay. Okay. Then how to modify the statement? So co-group, take one more relation. Co-group with inner join. Right. So take one more relation CGI to indicate inner join. So co-group post by user. Here just say inner. That's it. All by user inner. Okay. So what happens then? What happens then? So you be getting the inner join here, right? So like this, on a given data set, you can work on co-groups, joins, and everything here, right? So we need to work on some advanced joins also, like replicated joins and skewed joins and merge joins also. So in our next session I will be showing, because some conceptual discussion is also required for that. So basic idea you should have what you mean with that replicated and skewed and matched. Then I will show you some simple example also. Okay, some workout
Oh,
example.
sure.
Yeah, and like the way we'll go some medium level exercise also in tomorrow's session to the advanced
Okay.
level.
Okay.
Right. So any doubts, Naresh? Is it fine? Are you following this?
It's fine for me. I'll go and I'll do some practice. Some
Okay.
practice and everything. So let's see what is going to happen. So if everything goes good, that's fine. If not, well, yeah, I'll let you know tomorrow.
Sure. And yeah, started working that hands-on part, right? Tomorrow, if possible, I'll share some commands guide to you so that you can recollect the commands and all, you can do the practice.
Sure, sure,
And
sure.
just I had to verify, because it's somewhere I kept in my folders only. I had to get. I just verified upload to you so that you can practice the commands also what we did in our previous session. And along with I'll be uploading the scripts and the data sets to LMS. So please go through that and you can download that and you can do the hands-on part from your side.
Sure.
Right? Yeah. So tomorrow session we will be working on some advanced things like working on the replicated, skewed, and merge joins and XML parsing, and and if and all possible, we'll be showing some JSON parsing also, how to the JSON data is going to be parsed with the help of PIG, and some other stuff also we're going to see tomorrow. Okay. And UDF part we'll be covering at a time, with along with the high map reduce concepts and everything.
Okay.
That requires some Java knowledge. That's it.
Sure.
Okay, fine. So let us stop the discussion here. See you tomorrow. Thank you.